So in this video, I'll be talking about how you get the density of a cylindrical wooden log on its side in water. So first, let's draw this. Got a wooden log of length of L, a radius of R, and you got water in it with a height of H. That point, and we want to find a density. This is a perfectly cylindrical log, so that makes it easier. So first, there's no net force on the log as well, but there's a buoyant force. We got to make sure also no velocity is happening. The water's not moving, so the log isn't moving, and there's no acceleration due to the no velocity. So there is a buoyant force. You can say the density of water times the area of the water is equal to the density of the water times the area of the water is equal to, say, the buoyant force of the water. But the buoyant force of the water also is equal to the buoyant force of the log. So you can do rho density of water, cross-sectional area of water is equal to the density of the log, say L, times cross-sectional area of the log. The problem here is find a cross-sectional area of the water. So as we continue, we have the area of the log. This is a circle. So area of log. So that's this pi r squared. The problem is the cross-sectional area is more like a smiley face or open mouth. And this will not be easy to find. The easiest way to find it, so let's say area of water, would actually just to be circle minus the top that is missing. So to find this top, let me swing down a little bit. Have a little bit of a cone shape, since this will actually go a little bit down. So as we continue forward, make a triangle, make the arc length. Here to here is H. Here to here, I believe, is H minus R. Got R here, R here. Let's see if that's actually, and then you can name this any variable. So let's do Z. So the entire arc length, so there's a theta here and a theta here, and so that is not H minus R. Let's see if I can, oh, thank God I can erase that. This is R minus H. So we got that, and we got theta, so the angle it creates. This whole entire arc length, so arc length is equal to 2 theta. 2 theta, and you divide it by the radians in a circle times the area. So pi r squared times the area I'll make this the actual circle that we're going in. And just pretend that's the center, even though this is a very poorly drawn circle. But, so you do that, pi cancels out, 2's cancel out, this arc length is equal to theta r squared. Now, from here we can do some trigonometry. So you can do the cosine of theta is equal to r minus h, or h. And then let's do some simple algebra. You get cosine 1 r minus h. Oh, not over h. My bad up here. It's r minus h over r. So, simple math error is equal to theta. And now that we got theta, we can go back to this is what we found. So that arc length now we have r squared cosine negative 1 r minus h over r is equal to the top shape area. But now I need to find the area of the triangle. So I'll start this on a new page since I'm not going to remember. Let me redraw this triangle. Ooh, that's a bad triangle. Bad. So let me redo it. We said r minus h r. And we made these z. Couldn't name that any variable. So area of a triangle is base times height. So area of triangle equals base times height. So the base is this z. So you get z times r minus 8. And then since it's a triangle, you have half. So that equals equal to area. The problem here is we don't know what z is. So we're going to have to substitute. The only way to find z is Pythagorean's theorem. So what we know is that is the hypotenuse. So we have r squared is equal to z squared plus r minus h squared. And as we continue to do this down, r equal to z square root of z squared plus, ooh, no. No, I'm trying to get z on the side by itself, not r. So z squared is equal to r squared minus r minus h squared. Z is equal to r squared. And now let's FOIL. So you get minus r squared minus, actually that's this, so you get r squared. Let's put a parentheses out in there so I don't get signs confused. So r times h minus 2h minus h is plus h squared. And now we can cancel. So minus r squared, cancel out with that. So you'll get z is equal to square root of, so you subtract that, you get 2rh minus h squared. Now that we have that, we can plug it in for substitution of z. So you'll get square root 2rh minus h squared times r minus h and then half equal to the area of triangle. But that's the area of one triangle. We have two, so we can multiply this by 2 expression, and we can just get rid of that. So that is the area of both triangles. So now we need to subtract. So it's going to be, I do not have draw on. That's my bad. We have area semi minus area of triangle to equal area of overall. So let me make that a different area, which I called all the way up at the top. It's not the area of the water. So I'll just make it area of say area, even though it's not area. I don't want to name it air. Let's say height. So that's the height. So area of height. So let's move down. You'll get the area. So that's r squared. Oh man, I don't remember. Let's see. R squared, okay. Squared cosine -1 plus h minus, so big brackets, square root of h plus h squared. These are not this h is equal to a of h. Now that we have that, we can finally get a of smile, or open mouth, which is equal to a of area minus a of h, which in part is this little open area. So as we do that, the area of the circle, so say it's equal to pi squared minus this expression above, so r squared cosine 1 . So that is the area of the mouth, which is what we wanted from the top. So now we have density cross cross-sectional area of the water, which in this case it's open mouth, is equal to density of log, is area of log, which is circle. And I'm going to pick this up at the beginning of the next video.